Good morning, and thank you for joining us on this week's Tech Tuesday. Today's topic is Sick Dust Hunter for ESP tuning and broken bag detection. We have Phil on the line, and before I introduce Phil, I'd like to share that a recording of this webinar will be emailed to you following today's presentation. Also, throughout today's presentation, feel free to ask questions anytime by typing your questions into the Q&A box on the right-hand side of your screen, also in your control panel. So, I'll turn time over to Phil.
All right, thank you. Thank you, Lisa. Good morning, everybody. I'm excited to be here. It's a little bit awkward, so I'm hoping you'll give me a little bit of, cut me a little bit of slack today. I'm a strong proponent in the philosophy of God gave you 2 ears and 1 mouth, and you should use them in that ratio. So this WebEx format really puts me more as a lecturer and a speaker. I do want to make this process as iterative as possible so that I can get your questions answered, and we benefit from this. So please send in questions as we move along. If something doesn't make sense, something you'd like more details, if it's something I can answer right away, we'll do that at the end of the presentation. If it's something that I don't know the answer to, trust me to find the answer and get back to you, okay? So today's discussion is really combining two process measurements, so electrostatic precipitator tuning and broken bag detection. But before we jump into the dust hunter, I always feel it's best to just give you an overview, make sure, kind of like when you get on the plane, if everybody remembers that, you want to make sure you're going to the right place. So just look over the agenda. If this is not something that's of interest to you, now's a good time to get 30 minutes of your life back. So in this order, we'd like to go through just a short identification of who SICK is. Some of our repeat customers know that story, but it's worth mentioning. Really just the hierarchy and bragging about the legacy that we have with our dust detection technology. And specifically, we're going to get into the Dust Hunter SP30, some of the unique design features, a brief touching on the electrostatic precipitator application, and really more time, auto sync decided to kick in at the right time. And then getting into the broken bag detection. And then just a conclusion to recap everything. So always with new acquaintances and customers, the question is always, who is SICK? And I've worked enough trade shows over my 18 years with SICK where people try to create an acronym, and they come into sensor for the S and intelligent for the I, and sometimes even for C, we can get into cement or some of our other industries, but the K is the one that throws everybody off. So please rest assured there is no acronym. That's a family name of the founder of our company, Dr. Erwin SICK. And really the dust, it's worth mentioning because the dust product family was his passion. And so always, he was an inventor, an innovator, but always with safety and protecting people was his focus. And so with a lot of the optical devices that, in particular the dust monitors, I remember hearing the story early on with Dr. Sick's first factory abutted against a local regional airport. And he was fascinated on a foggy evenings of the beacon that alerted pilots that the airport was open, and that vision of the beacons pulsing and strobing through the night, and he could see different dust particles, and he could see the fog, and he could see how far the beam would go. That was really a basis for a lot of his inventions. And again, safety related, protecting people. In this case, improving processes. And so we've got a long portfolio. I don't want to make this a commercial into everything that SICK has to offer, but really if you look around your offices or your home offices today, something is there that a SICK sensor touched or controlled or guided. From labeling, packaging, the natural gas that eventually finds its way into your home or business, all these products and innovations are brought by SICK. And of course, new business. So at the end of this presentation, if you have an idea for something new, one of the strengths in SICK is we're always looking to develop new solutions, make life better, make life safer. I mentioned this legacy, and it goes back to 1945, obviously, but some of these models you may be familiar with. Some of these models are probably before your time and my time. And a lot of them that are pictured here have a different name on the outside of the box. Early on in the 60s and 70s, a lot of the dust analyzers that we marketed into the U.S. Had a different company name on it, so we didn't have the presence here yet to support EPA and compliance regulated measurements. Really at the end of 2008, the FWE 200 was really maybe the dust analyzer that put SICK on the map, so to speak, with our name, with the innovation, being able to measure particulate in a wet environment. This was new, and something we're really proud of. From there, I wanted to jump in particular on the Dust Hunter SP30. So the SP30 is a new analyzer, a new monitor, and unlike the other developments that you saw on that chart, that timeline, this is really a simpler analyzer. And so it seems as regulations got stronger and tougher, not only globally, but in the U.S. in particular, always analyzers and monitors had to become more complicated and more complex. And that's why I got excited about the SP30, and I wanted to do this presentation and for customers, and in particular power plant customers. This is something that's different for us. It's simpler. So we've taken out moving parts. We've made it more basic, and along with that, we've made it inexpensive. And so the idea was to actively fulfill a need in the market for an inexpensive, accurate way to monitor dust. And so I have to, some of this is a little bit dry, but I have to at least lay out the specifications and also introduce you to the technology. I think that's probably a good way to start. What's significant here, and we'll get into each of these a little bit in the following slides, but for you to realize this is a scattered light device, and in particular forward scatter. We'll get into what that means in a minute. The spectral range isn't as important. It just tells you the laser power and the laser operating spectrum. And measuring ranges is very significant, and that's what makes this monitor very versatile. So we go from 0 milligrams per cubic meter all the way up to 3,000 milligrams per cubic meter. So it's a very extensive measuring range and gives us the versatility. Accuracy is right up there, what you would expect from a scattered light device. And then the packaging and the testing is, again, everything you would expect. So essentially, we've got 2 models depending on the length that need to go into the ductwork or the stack. And optionally, and this is what goes into that claim that I've made about it being inexpensive, you do not need a control unit. Everything that you see on the left side here is standalone. And so you don't need an extra device to get your output or your digital input. And so that's a way we can make the unit less expensive. Also, we do have an optional purged air unit. So this, as it comes out of the box, for most applications, the purge air is not required, but it is an optional feature. Excuse me a second. So scatter light forward. It's a technique that's used worldwide. It's not something that I bragged about Dr. Sick earlier. It's not something he invented. This is a very common measuring technique for measuring dust particles. I'll get into what the forward means. So if you look at the, wait a second. If you look at the measuring cell, you can see this is where we're measuring the dust as it's flowing through the ductwork. In this case, it's laid out at like a stack. And we've got a sender unit, so that's located in this, the laser resides. And then we also have a detector. So the detector is also laid out in this module. And so what we're doing is sending the light beam through, and then it's being collected on a fiber collector, and the fiber is coming back with that light into the detector. Now, what we're calling forward scatter is occurring here in this measuring path. So our light beam is coming this way, our detector is this way, and what we're seeing is our light beam reflecting off of the front of the dust particles. So that's hence the forward scatter, forward or front. And we have different techniques. In some cases, we use back scatter for other applications, but for the Dust Hunter SP30, forward scatter was the best and most robust and gives us that wide detection range of different particles. So the benefit there, it doesn't matter what velocity you have, how varied your humidity or particle charges are of that dust. And again, it's been a proven technology. This isn't a beta type technology. This is something that has been proven over the years in the laboratory and a lot of our other installations. What's a little bit different is the way that we do our control cycle. It's a way to measure the integrity or really determine the integrity of the measurement. And so you've got your light beam from the laser. Typically, it's crossing this plane here. And we do is step the intensity of our laser from 70% and 100%. So when we do that, you can see on this chart recorder, the step changes that you would expect. We turn the laser off in the next step, and that becomes our 0 point. And you can see here how that would be indicated on a chart. So this happens every 8 hours. You can change it. We'll get into SOPIS in a minute to show you how you can do that in SOPIS, our software, but it's user selectable. So it's a stable measurement, maintenance-free intervals, and very low maintenance cost. Just briefly, just show you, I mentioned there was 2 basic different models. So for the smaller duct work and smaller path lengths, we've got threaded tri-clamp, and we can also go with like a flange that's welded onto the ductwork and with a larger length. So no matter what size your duct, we've got the right length available. A lot of words here on this slide. I'm not going to get into all the details other than what makes this unit so versatile is the fact that there's 2 calibration curves and 11 measuring ranges. All can be selected from the analyzer itself, the monitor itself. You don't need a control unit to do that. And so this gives great flexibility. So high concentrations, low concentrations. It also eliminates the need to do a gravimetric correlation. So you can set these ranges based on what you know, and you can set 2 calibrations based on changes that you anticipate. I mentioned the available purge. I think it's important for you to understand that that is not required, but again, what's kind of neat is with the purge, you've got a sensor status light on the outside, and then without it, you just got the sensor status. So when you have the Purge unit, you also do have a little LED bar indicating your integrity of your Purge. So it's a visual indicator. You don't need any other type of control module. So it's very simple to set up. And with the auto regulation of the back Purge, it's very low maintenance. So typically, and this is what I got excited about, typically for broken bag or ESP applications, a tribal electric type technique is used. And we got into how we're using forward scatter. I'm not going to get into the details on the tribal flow, other than it's an electrostatic measurement. And we did some benchmark testing versus the tribal flow. And for a lot of measuring applications, there are some weaknesses. So there's a velocity weakness. For tribal flow, you need to have a continuous velocity. There's a contamination issue often that causes drift for the accuracy and the repeatability as dust particles cake up on the rods. And often this requires maintenance. Someone's got to clean the rods. So for high concentrations, typically tribal flow doesn't work very well. It is suitable for really small duct work. And I showed you that earlier, that little self-check we do. There is really no way to do that with the tribal flow type technology. And certainly with all the electrostatically charged particles coming directly off of a electrostatic precipitator, tribal flow is just not recommended. Just a visual. This is a side-by-side benchmarking our SP30 versus tribal flow, and you could see how the SICK analyzer picked up some of these distinct peaks and spikes that would be related, in this case, to broken bag detection, whereas a tribal flow device, you can see it just really didn't trigger much of an event at all. So again, if your application and installation is always constant, and the dust particles are always charged the same, and if you don't need linearity, then tribal flow would be a way to go. You're just looking for some basic indication, very wide, accurately measured trend. If you really need to measure your dust load, independent of those items and those factors, then scattered light is the way to go. So the SP30 we really, again, developed for, I got to put the disclaimer out there. Emissions monitoring where regulation compliance isn't required, is not required. Leaking filters on baghouse, that's really what we're going to spend the rest of the morning discussing. ESPs and cyclones, and then dosing is probably more steel related and not so much in the power industry. But it's a typical layout. Got your dust collection system here. This is a rendering of a typical electrostatic precipitator. The dust hunter on this application, we would imagine being installed in this ductwork here on the exit. And really, the only control that could be realized would be maybe your wrapping sequence. We found early on when we developed the wet PM SIMs that often the wrapping sequence for the ESP was way out of sync, and this caused excursions well above emissions and permits. So we would envision the dust hunter being alerting you of that before it became a problem further down the line. On baghouses, there's a lot more to the story. Typically, these are fabric filters and cylinders. You can see these layouts here. And compressed air is blown through on some regular pulses to clean the bags off of the dust. It's a little bit better image of what's going on inside. You've got gas coming in. In this case, this is a jet bag cleaning system. So you've got a pipe and valves that allow these bags to be blown out. Solids are collected down at the bottom, and this happens on a regular sequence. So these are usually done in a timing sequence, and I'll show you a little bit more complicated slide here, but we've got to talk about it. So the key is to synchronize the SP30 to your bag house cleaning cycles. And so you can see here, here's the signal coming into our dust hunter. And you can see these time intervals, the sawtooth here, and what happens when broken bags occur. And these are specifically filter numbers. So there is a delay here, and we can build in that delay as well. And I'll show you in a second how that's done. So I mentioned this Sopus software tool. You can see this is a setup. It comes with an analyzer. It's not an option. It's not something we charge for. It's no charge, available at our website. You can label which filter. We call it the filter watch mode. You can configure the output. This is where you set your time interval and then the time between the pulses. You enter how many bags that you've got, and you assign a dust limit. In this case, this was 50 milligrams per cubic meter. And then we go for a sync this up with your cleaning cycle. In this case, we can dampen the concentration. We can show which filter failed or are broken. Shows you which filter number it's on. And we'll trip a relay on a signal if it's detected as broken. So this is the most common filter configuration. I'm looking at the clock. We're running a little bit short on time. I want to leave some time for questions. So, but this would be a layout where the Dust Hunter SP30 would really shine. So the key here is that the valves are individually activated. So that's represented here in these different chambers. And so knowing which valve is activated at the time, with that built-in delay time we showed you earlier, the Dust Hunter SP will determine which bag in this row had an issue with breakthrough. And you can see that indicated here. A large peak that occurred at that particular time. So it's really a timing sequence, knowing where the cleaning was being done at the time the Dust Hunter saw an excursion. So in conclusion, it's a standalone design. So it's very simple, cost efficient. You don't need a lot of extra bells and whistles. We've got both analog output and Modbus that would come directly from the sensor without having to go to any type of alternate or extra piece or box. So that gives you very easy commissioning and startup. And then different mounting options and probe lengths. So we're not stuck with a one-size-fits-all type mentality. We're able to provide the right solution for what you have on your site. And so this makes it adaptable for multiple types of bag houses, multiple types of ESPs. And because of the wide detection range, you can see that we're able to measure anywhere from 0 to 3,000 milligrams. And then the last feature of the calibration curves, the two calibration curves being stored in the sensor, gives you a lot of versatility and also capability of different process conditions. So that gives us that flexibility. So with that, I think I've left a few minutes for questions. And for sure, you have my email address and my phone number. So if you have questions offline, please feel free, give me a phone call, send me an email, please.
Thank you, Phil. As a reminder, I will be sending out a post-webinar email that shares Phil's email address and contact information, so you have another source to collect that. But thank you, Phil. And yes, we'll go ahead and take some questions. And Phil, I have one for you. The first question comes from Lewis, and he says, in which cases do you recommend the use of SP30 instead of SB30?
I think low dust, for very low dust, the SP30 is better. The SB gets us into hotter temperatures. So I guess one of the limitations for the SP30 would be the 200 degrees C. And so if for most fabric bag houses, that's not a problem because most fabrics can't exceed that temperature anyway. But if your application is hotter than that 200 C, then I would go with the SB configuration.
Awesome. Another question is can a contact input start the filter watch? And from that point, is it based on timing only?
Yes, and that is, a caveat. Yes, so you can drive it externally. So, but yes, from that point on, if that cycle or sequence is interrupted, you would have to start that again. And again, the monitor will still, identify an excursion. But if your timing sequence is off, you've eliminated that capability of identifying exactly which bag it is. So you'd be alerted that there's a problem, but you'd have to kind of hunt and peck to find it. That's a good question.
Great. This one comes from Joseph, and he asks, can the unit still be able to identify which bags are broken if the dust collector pulses are triggered by DP and not time?
No, we would have to know. Well, it depends. If they're doing that as I'll back up a little bit. Typically, no. In what you just described, there may be multiple valves firing in that particular situation, and so there we would be able to tell you what row, but not what bag. So we would be able to identify what row of bags had the problem, but we would not be able to identify exactly which bag because that sequence was not in our SOPIS.
Great. Those are all the questions I see. So Phil, if you have anything else to add, I'll give the space back to you, or else we can end today's webinar.
Yeah. All right. Yeah, just a quick closing. I wanted to thank everyone. This is a very challenging way for me to present. So I can't read faces. I can't see reactions. So like I said at the beginning, I feel like I'm preaching or lecturing, and it's a little bit awkward. So I appreciate you sticking through me with it, and look forward to us all having a great year and staying healthy. Thank you, Lisa.
Thank you.
Thanks, Phil.